the night skies of October and the influence of the sunspots on Earth. This is given by, I'm happy to introduce Harold Hester. We are all familiar with him. I think he has been doing this for the past 2 years, introducing the night sky, and I'm sure everybody is looking forward to this. Over to you, Harold.
Thank you very much, Prof. I think everybody can see the title there, the night skies of October. And then we're also going to discuss, I said sunspots, but it's also the strongest electromagnetic storm to hit Earth in 20 years. The picture is a picture of the Eagle Nebula, and I think that's taken by the James Webb telescope camera. Okay, next slide. That's for you to change, Gihan. All right, as usual, I put my references up front because I think they're very important. The one on the left, there are two books. The one on the left is the 2024 Guide to the Night Sky by Storm Dunlop and Will Tyrion. And the one on the right is the Night Skies of Botswana. Now, they both give charts for every month. I particularly like the 2024 Guide because the charts are very easy to follow and very easy to see. It shows looking north from where you are to looking south, and it shows everything that you can see, the major items in the night sky that you can see. So next one, please, Gihan. This is a picture looking north. First thing to look for, to get your bearings, the first thing to look for is the Milky Way, which is on the western side of the sky, and then the ecliptic, or the zodiacal line, which is the imaginary line followed by the sun, the moon, and the planets. And I've put a dotted line in there for the ecliptic line. So that gives you your bearings. Then you can look for, firstly, the one to look for is Scorpius, which is our winter constellation, and that is slowly disappearing to the west, setting to the west. And you can see that in the top left-hand corner, Scorpius. Antares is the brightest star in Scorpius, and next to it you'll see a little smudge called M4, and that's the closest global. Let me get this right. Sorry, it's the closest cluster to Earth or our solar system. So if you go across, you can see after Scorpius, you can see Sagittarius with the upside down teapot that's in the Milky Way. Then Capricornus, which is close to our hearts, being our logo. Then carry on is Aquarius, the water bearer, with Saturn. Saturn is the only planet visible in the nighttime. When I say it's sort of from about 9, 10 o'clock at night. You can see Saturn, that's in Aquarius. And then Pisces over towards the east. And Aries. Right down on the northern horizon is our nearest other galaxy, which is Andromeda. And you'll see, of course, you'll see the large, no, you can't see it on this one, sorry. Yeah, so those are the main items of interest. I'm not going to spend too much time here because I want to spend more time on talking about this electromagnetic storm which we've just experienced. Okay, next slide, please, Gihan. So this is looking south. Again, you can see the ecliptic, which I've put in. And this time, Scorpius is on the right, and that is sinking fast to the west. The other items of interest, of course, is down below near the southwestern horizon is Centaurus and Crux. You can see Crux there quite clearly. And then Centaurus going around Crux. The interesting one there is Omega Centaurus, which is the largest cluster that we can see in the night sky. Omega Centaurus is always a very good item to see in the night sky. Then, of course, we've got the Large Magellanic Cloud. You can see it's just below Reticulum. And then the Small Magellanic Cloud near 47 Tucanae. I think those are all the major items which I've highlighted that one can see in the southern sky. Okay, next slide, please. Right, planets. The planets that we can see this month. Mercury, in the bottom, on the right-hand side on the bottom, there's a little picture of the daylight on the left and the daylight on the right. So the left is so you can see that Mercury is in the daylight, so it's not visible. It's still behind the sun, but may become visible in the evening. Venus, so the left is the evening. Venus is the bright evening star in Virgo. You can see that brightly just as just after the sun sets. A very good view of Venus. You can see Saturn is almost in the middle. That's why it's virtually the only planet you'll see during the night. Jupiter you'll see shining brightly in early hours of the morning, and Mars you'll see just before sunrise. So Mars will be in Gemini and will be seen before dawn in the east. Saturn will be high overhead in Aquarius. Then of interest is new moon, 2nd of October.
The keys of the car.
Sorry, somebody else is talking. Okay. So full moon, 17th of October. The best time to do any stargazing, of course, is around about the 2nd of October. So unfortunately, that's during the week, so you'll have to wait for the weekend, which will be either this weekend or round about the 5th of October. But it'll still be a good sky to look at.
Sure.
Okay. So next slide, please. Now, for the first time for many years, on the 8th to the 10th of May, auroras were seen on the Cape Coast and Little Crew in South Africa, and also in Australia and New Zealand. And I've shown some pictures which were taken, photographs taken in Cape Town and East London. Normally, one associates these auroras with the Northern Hemisphere, Finland, Sweden, Norway. But here we saw them in the south. And for me, that was quite an exciting event. I wish I could have seen it, but I couldn't. I just had to read about it. And that's what I'm going to be talking about now. Why did they see an aurora in Cape Town and East London on the 8th and 10th of May? And will there be an opportunity for more auroras later? Next slide, please. Right, the auroras were the result of a ferocious solar storm. Now, the cause of these auroras was a cluster of sunspots known as an active region 3664. If you look at the sun in the quadrant around about 4 o'clock, you can see a very bright part. That is the active region 3664. So that appeared below the sun's equator on the side currently facing Earth. That cluster is around 17 times as wide as Earth, although it looks like it's just a small light there, and probably the largest, most complex sunspot region observed during the current solar cycle, which began in 2019. So, starting around the 8th of May, the active region 3664 sent at least 7 blasts of magnetized plasma, or coronal mass ejections. Just remember that, CME, coronal mass ejections, racing in the Earth's direction at speeds of up to 1800 kilometers per second. Next slide, please. You can see the dark spots in the picture on the sun. Those are the sunspots. And they are dark because they're cooler than other parts of the sun's surface. And the temperature of a sunspot is still very hot, although it's only around 3,600 degrees Celsius. The rest of the surface of the sun is 5,500. So these are cooler. And Why are they cool? Because they form at areas where magnetic fields are particularly strong. So the magnetic fields hold, they keep some of the heat within the sun, and then they suddenly burst through. Individual sunspots or groups of sunspots may last anywhere from a few days to a few months, but eventually they decay. Next slide, please. So I mentioned the solar cycle, and the solar cycle lasts for about 11 years. And you can see this was the previous solar cycle, lasted from 2010 to 2020. So the current solar cycle is lasting from 2021 to or the end of 2020 to about 2031. So we are right in the middle of the solar cycle. And what characterizes the cycle is that there are very few sunspots at the beginning of the cycle, and the sunspots and the coronal mass ejections are at their peak in the middle of the cycle. So that's why they saw that corona borealis in the Cape, was because we're approaching the middle of this cycle. So the giant eruptions on the sun, such as solar flares, also increase during the solar cycle, and these eruptions send powerful bursts of energy and material into space. This activity can have effects on Earth. The eruptions can also cause lights in the sky called aurora or impact radio communications. So just to repeat, the solar cycle lasts for about 11 years. At the middle of the cycle, the sunspots are at their greatest, and also these coronal mass ejections are at their greatest in the middle of the cycle, which we're approaching now. Okay, the next one, please, Gihan. So here you can see the spots on the bottom on the left. You can see the dark spots, and then you can see the plasma just being thrown out. So a solar flare is a relatively intense localized emission of electromagnetic radiation in the sun's atmosphere. Flares occur in active regions and are often but not always accompanied by coronal mass ejections, solar particle events, and other eruptive solar phenomena. Solar flares are thought to occur when stored magnetic energy in the sun's atmosphere accelerates charged particles in the surrounding plasma. This results in the emission of electromagnetic radiation across the electromagnetic spectrum. Okay, so there's this huge electromagnetic blast coming from the sun towards Earth. You can see Earth in the background there, but that's not to scale. Next slide, please. So this shows better than what I'm trying to explain. You see the sun on the left, and on the right you can see the little Earth with the magnetic lines going round on the left and the right, but they've been hugely distorted. So a geomagnetic storm, also known as a magnetic storm, is a temporary disturbance of the Earth's magnetosphere caused by a solar wind shock wave that's coming from the electromagnetic, the sunspot, which is suddenly exploding, releasing all this coronal magnetic eruption and ejection, and it comes towards Earth, and it blasts at Earth in a really strong way, and messes around our magnetic lines. Next slide, please. So this shows an artist's impression of what I'm trying to tell you. You can see the solar wind coming from the left, and you can see the Earth's magnetic lines. The solar wind also carries with it the sun's magnetic field. This field will have either a north or south orientation. If the solar wind is energetic bursts, contracting and expanding the magnetosphere, or if the solar wind takes a southward polarization, geomagnetic storms can be expected. The southward field causes magnetic reconnection of the day side magnetopores, rapidly injecting magnetic and particle energy into the Earth's magnetosphere. So the auroras normally occur at the polar regions, but when it's a very, very strong eruption, the auroras appear further from the poles. And that's why the Cape and Australia and New Zealand saw these eruptions in the beginning of May this year. Next slide, please. So we're nearing, as I said, we're nearing the peak of the 11-year cycle of activity regarding sunspots. And the dazzling auroras are just a warm-up as more solar storms are likely. Now, what to expect in the next few months and beyond as the sun hits its maximum? All right, let's have a look. These are the three previous solar cycles. The first one from about 86 to 97. The next one was 11 years later. Cycle 24 was the one just preceding ours now, and ours is not shown here. But what they're saying is because that storm, the 8th to 10th May, was so big, it's likely that the cycle we're in now, cycle 25, is going to be as big or bigger, be more eruptions shown on the solar cycle on the left. You can see cycle number 22. So we'll probably have more eruptions than they had in the late 80s and early 90s. Be many more and maybe stronger. That's why that aurora appeared at Cape Town. It was a curtain raiser to what we can expect between now, say, and the end of next year. Next slide, please. Now, just to mention the biggest, the most intense series geomagnetic storm in recorded history was the Carrington event, and that happened in September 1859. It created strong auroral displays that were reported globally and caused sparking and even fires in multiple telegraph stations. Now, I mean, those telegraph stations were very crude compared to what we have today, but these storms can still cause a lot of damage today. And so a geometric storm of this magnitude occurring today has the potential to cause widespread electrical disruptions, blackouts, and damage due to extended outages of the electrical power grid. So it could happen that our internet goes down, or we have long power delays due to these geomagnetic storms. Next one, please. So this was another picture taken in the Cape on the 9th and 10th of May 2024. Next one, please. So this is what it looks like. If you see, there's a black disc at the top of the picture, and then there's a circle. The circle is the size of the sun. And you can see these storms, how far they radiate out from the sun. So we're very small in this whole setup, and that's why we are so vulnerable to these sunspots or electromagnetic storms. This is an image of the July 2012 solar storm, which generated CMEs of comparable strength to the one in 1859. So, yeah, note the small bright circle is the light. Okay, next one, please. Now, Katrina. Katrina was very interesting. It didn't actually happen at the peak, but this was due to sunspots. They mentioned at the time, oh man, I'm going to be a bit of a maverick here. They keep talking about climate change and global warming, but people forget about sunspots. Sunspots have a huge influence on our climate. And if you see, Katrina was the 12th tropical cyclone, the 5th hurricane, and the 3rd major hurricane of 2005 Atlantic hurricane season. It was also the 4th most intense Atlantic hurricane to make landfall in the United States, gauged by barometric pressure. So, yeah, we've got to bear in mind that these sunspots have a huge bearing on our climate and what events taking place. Next one, please. So why have I discussed this? Because if the internet goes down for a while, I want you to know why it's going down. It's from sunspots. It's nothing that our guys can do to prevent it happening. And blackouts and the power outages are going to happen if we have huge CMEs. So we're unlikely to see these aurora effects in Botswana, but if we do, if it's a very big storm, we will see it in the south of Botswana, and that will be something fantastic if we can see that aurora in the south of Botswana, and it could happen on this cycle. Next picture, please. So the Northern Lights have been quite active over the... Now, this was something I saw on the internet last week. They were predicting Northern Lights in Britain on September the 15th and 16th. And the colors are from the gases which are in the atmosphere. So nitrogen and oxygen are the two most common gases in the atmosphere, with nitrogen emitting purple, blue, and pink, and oxygen emitting green. So that's why it changes all the time. When you've seen pictures in Norway and Finland, Iceland, it's all due to the gases there and impacted by these coronal ejections. Next picture, please. This year, the Sahara Desert has experienced an unusual heavy rainfall event last month, September. We're in September now. Yeah, this month, bringing significant precipitation to parts of Morocco, Algeria, Tunisia, and Libya, which don't normally have rain. And you can see the rain there, and these pictures were taken from a NASA satellite. Rare, heavy rainfall in the Sahara Desert. Now, don't you think that's very strange that this rainfall has occurred at the same time we're getting these coronal mass ejections? Next slide, please. These are floods taking place all over the northern hemisphere. Europe, India, China, Indonesia, Britain, they're all having heavy, heavy rains right now. At the same time, the Cape is getting this corona borealis effect. Also, don't forget that last year, Cape Town had more rain than they'd ever had in recorded history, and Durban had a lot of rain. We here in Botswana weren't so lucky. But I think there's a very, very strong likelihood that this year we're going to get a lot of rain. And guess what? Everybody's going to say climate change. But you know, and I know, that it's going to be due to sunspots. The arrival of sunspots in our magnetosphere are going to cause huge rainfalls. So let's wait and see if this little old man was right or wrong. And that's the end of my story. Enjoy the rain when it comes, because it's coming.
Thank you very much, Harold. Thank you. What a fantastic and informative session. Thank you.
Thank you very much, Harold. I think we have some time for some maybe comments and questions.
Can I ask a question?
Yes, please,
Yeah.
Dave.
Harold, I've got two questions. One is that, can you just make clear for me what's the difference between a cluster and a constellation? Or and a galaxy?
Okay. A galaxy is, well, like the Milky Way is a galaxy. That's got a whole lot of constellations, stars, nebulae, all different globular clusters, open clusters. Everything is in the galaxy. That's an all-contained thing. Andromeda galaxy is the one nearest to us. We're going to hit that in 5 billion years' time. The constellation is just a group of stars, and what we've done is we've tried to be able to identify them, and everyone's on the same page. They've put them together, and they've said Sagittarius looks like a teapot, and all those stars in that area, which they look like they're close together, but they could be a long way apart. But that's the teapot, and that is the constellation of Sagittarius. It's just a way of identifying it. So you would find that the Chinese would have different constellations made up of different stars. The San will also have different constellations, and that's what this book that I mentioned earlier on, the one by whatever his name is, Steve, that shows the Stan. And the San's constellations are mainly animals and water. So you have giraffe and lions and all different animals in their constellations, which will be very different from our constellations. It's just a way that different cultures and societies have of identifying the stars up in the night sky. Then we've spoken about globular clusters and open cluster. A globular cluster is a tightly bound group of stars which haven't broken. They're held together by magnetism, and which the omega cluster is the best example. Then there are open clusters like there are many, like the Magellanic Clouds. Those are open clusters. And you've got nebula, which are stars being born, new stars being born. Does that answer your question, David?
Yes, thank you. I mean, presumably clusters are held together by gravity.
Yes.
Okay. The other question, a quick one, is that you mentioned the effect of sunspots on the climate. I've read also that the sunspots have quite a strong effect on the long-term climate. In other words, we can look forward to certain climatic conditions linked to the sunspots. Is that correct?
I would think so, David. They talk about El Nino and El Nino. I can't remember, but if we have a lot of sunspots, I would think it will warm the ocean, and that affects our climate. So who knows? I've now become aware of it. I'm certainly going to be watching out for this. So it might help us with rain in the next few years. I don't know, but I would think it would. I would agree with you.
Thank you.
Harold, this is Jay. A question. I read that the Saturn rings may disappear for us somewhere in early 2025. Is that and you mentioned Saturn being visible possibly in the midnight sky, and how much will we be able to see the rings with the naked eye, or do you need a powerful telescope to see the rings of the Saturn?
I think if you use a pair of binoculars, you'll see the rings.
Okay.
You won't see it with a naked eye. I don't think so. But with binoculars, you'll definitely see it.
And you said around midnight, isn't it?
Yeah, probably from about 10 o'clock.
Okay.
Maybe 10 o'clock or so. Yeah.
All right. No, thanks, Harold.
Okay.
But Harold, the rings of Saturn will disappear though as they go end on to us.
Yes. Are they doing that now, David?
Yes.
But yeah, but right now they probably won't be perfectly end on.
No, they're not yet, but it's getting that way.
It's getting that way. Yeah. Okay. But that's also just a temporary occurrence, isn't it?
Yes, it's just to do with this with the orbits.
With the orientation. Yeah.
Yes.
The orientation. Yeah. Okay.
Okay, thank you very much. I think I wish to thank, and I think on behalf of everybody here, thank Harold for that really very interesting, fascinating presentation. I don't know whether there are any more questions, but I think it's getting to be time to start our annual general meeting. Now, the thing is that we have arranged the annual general meeting to follow the same link. And therefore, I think from now on, those who are members of the society can remain on this link. So thank you everybody for attending. Thank you, Harold.
Pleasure.
Thank you, Harold. That was very fascinating.
Yes, yes, it was very nice. Very, very nice.
It's a pleasure. I'm glad you enjoyed it.
Oh, extremely, extremely.
May I address Mr. Robin McLucky? I wonder whether you're
Yes.
hearing me. We are going into the Astronomical Society annual general meeting now for the members. So may I thank you for attending the presentation. We will be continuing on the same link into our annual general meeting.
Thank you very much.
If you have any questions from Harold, you could ask him now. And thank you for attending the presentation.
Okay, I think we can start our annual general meeting. And I think I wish to welcome everybody. I think Fulvio has also managed to join us. So I think maybe let me just refer to Gehan to let us know whether we have a quorum.
We don't have a quorum at the moment. We have 13 present, excluding Mr. Robin McLucky. We have 13 present here right now, and